So the last thing that we should probably talk about in this module is kind of the general testing of multiple restrictions. So we kind of concentrated on exclusion restrictions, which are when testing whether a subset of these independent variables have no effect on y. So the testing whether those betas equal 0, but we can also test if those betas equal some particular number as well. So let's just talk about that briefly. General testing of multiple restrictions. It's essentially we're doing the same thing, but we talked about these two versions of the test, the R squared and the SSR, and here's where we have to be careful about which version we might use depending on what our null hypothesis is. So let's say we have this regression that looks like this. Let's just leave it like that. And let's say the null hypothesis, for whatever reason we want to test, is that beta 2 equals 0 and beta 3 equals 1, which means our alternative is that beta 2 doesn't equal 0 and or beta 3 doesn't equal 1. So we know that this is kind of, we've been denoting our unrestricted regression as 1, so this is our unrestricted regression. Now to come up with our restricted regression, we need to kind of put these restrictions directly into this unrestricted regression. So y equals beta 0 plus beta 1 x1, beta 2 equals 0, so 0 times x2 plus 1 times x3 plus u. So we know this is going to cancel out. So y equals beta 0 plus beta 1 x1 plus x3 plus u. We can't run this regression. I mean, there's no parameter in front of x3. So we're going to have to move x3 to the other side. So this is like a new dependent variable. So nothing about, you're still going to run this regression, but this means, so you're still going to run this restricted regression, but we need to use, the SSR version of the test. So this is an example of one of those times where we can't choose between the R squared or the SSR version of the test. We need to use the SSR because the total sum of squareds in regressions 1, and this is regression 2 down here, this is what we got to anyway, these dependent variables are different, which means the total sum of squareds, or the sum of squares total, is different, which means that algebra to get from the SSR to the R squared version of the test won't work. So this is just one of those examples where you need to use the SSR version of the test. Okay, so everything else about is the same. We'd run this regression, get the SSR, call the SSR unrestricted, run this regression down here with this new dependent variable, call that the SSR restricted. We have Q is equal to 2, N is equal to whatever it is. We get our F statistic and we calculate the p-value and check it against the significance level, or look up the critical F value and compare it to the F stat that we got, or compare our F stat to the critical value is maybe a better way of putting that. But everything else is the same. I just wanted to underline this because you need the SSR version if these dependent variables, if these dependent variables are different.